Good morning. This recording is for Algebra 1, Chapter 9, Lesson 7, using the quadratic formula. The quadratic formula is great because it means you don't have to factor and you don't have to complete the square to figure out the two solutions or one solution or no solutions for a quadratic equation. All right? Now the thing is that the quadratic formula is derived from completing the square, which is why I really wanted you to do the last lesson. Technically, you don't need to ever complete the square because we have the quadratic formula, but we need completing the square to actually get to the quadratic formula. So I'm going to go ahead and derive it real quickly. And deriving means to get from one place to another by changing it and getting something that looks different but means the same thing. All right, so we're going to start off with a quadratic equation, and we are going to basically get it so that a equals 1, and that means by dividing by 1, and that's like a quadruple heart right there. It's like a pitchfork or a trident or something, and we're going to end up with this, and basically a equals 1, which is good because we need that to complete the square, which we're going to do next. So we're going to take what I had from the first step and complete the square. But first I need to get C away from it so I can complete it. And then I'm going to complete the square. And then I'm basically going to, I believe I'm going to factor. Yep, going to factor. Couldn't remember if I factored first or simplified. So if I factored first, that means that I'm then going to simplify and add what's on the right. And again, I don't expect you to memorize this process of deriving. It's not really important until you get into much more complicated math, but you kind of need to see why completing the square was important to get us to the quadratic function. So even though after this point you don't have to use you don't have to use completing the square anymore, you need to understand its importance when it comes to the quadratic formula. All right. So common denominator for what's going on the right side of that equation down there at the bottom is 4a over 4a. So basically right there, see? And then also I simplified. I basically went from there to there. Okay? All right. Next up, we're going to add and combine like terms. There we go. And now I'm going to solve for x, which basically means square rooting everything. And I'm going to get that. And I can square root the bottom because it's a perfect square, which is another reason why I definitely needed to use the 2 here, the a here. Well, no, the 2, something like that, because of how things work out, and I need to be able to have a perfect square on the bottom. All right, so there we go, and I'm going to end up with this, and then I can minus 2ab. Oh, notice how perfect square divided, how I got from here to here, because the square root of 4a2 is 2a. Okay, and then I can subtract I can subtract b over 2a on both sides to get rid of that, so that I end up with x equals negative, and since the denominator is the same 2, see how catchy that was? I can easily subtract them. So I'm going to end up with the actual quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yay! This will save your life because now it means you don't have to do factoring, and it means you don't have to complete the square. There you go. Don't have to complete the square. But you still need to factor in other situations, so don't think that factoring is just no longer a fact of life for you. Factoring will be a fact of life for you for the rest of your math career. All right? But yeah, you really don't have to complete the square as much anymore. Okay, so the quadratic formula, there it is in all of its glory. You need to make sure you memorize it. Your teachers next year will expect you to be very familiar with it. You just need to know it. All right? Now, also be sure that before you start plugging anything into the quadratic formula, that your original quadratic equation is in standard form, which looks like that. Okay, let's move on. Let's actually use this. All right, so if we have the equation x squared minus 2x minus 8 equals 0, we're going to solve the equation using the quadratic formula. And just a reminder, solving a quadratic equation means we're looking for the x-intercepts. Sometimes there are 2 of them, sometimes there is 1 of them, and sometimes there are 0 of them, okay? So let's go ahead and use this to figure out the 2 x-intercepts, or 1 x-intercept, or 0 x-intercepts. All right, so I like to go ahead and, before I even start, write what A equals, B equals, and C equals. Well, A equals 1 because there's no coefficient in front of x. B is -2, and I can really look at it if I add the opposite. And C is -8, especially if I add the opposite there. All right? All right, so now I'm ready to plug this into my quadratic formula, which was -b plus or minus the square root of b squared minus 4a all over 2a. Like so. All right, so what I'm going to do is I'm going to go ahead and replace each thing. B gets replaced with -2. A gets replaced with 1, and C gets replaced with -8, and then it's just basically the order of operations. I got to take care of things inside of the radical first, and again, the radical is the square root. So step 1, I substituted, I just did that, that's right. All right, substitute in values for the variables. And step 2 is to simplify with the order of operations. And I'm going to take care of things inside the grouping symbols first, which would be the square root. -2 squared is 4. 4 times 1 times -8. And then subtract ends up giving you a positive 32. And you need to add everything inside the square root, which is going to give you 36, which it's going to end up writing there twice because I forgot it last time I wrote it. And we're going to break the remaining problem into 2, a positive radical outcome and a negative radical outcome. Because remember, it's plus or minus, which means one of them is going to have a positive outcome and one's going to have a negative outcome, like so. So let's go ahead and simplify each of these. The square root of 36 is 6. And so I have 2 plus 6 over 2, which is 4, and I have 2 minus 6 over 2, which is -2. So the 2 solutions, the 2 places where the parabola intercepts the x-axis is 4 and -2. Pretty easy, huh? A little easier than factoring or even completing the square? I hope so. So yeah, it's a little bit of math, but again, a little bit less brain work because you have the formula telling you what to do. All right, let's move on. If a radicand, which is the stuff inside the square root of the quadratic formula, is not a perfect square, you can use your calculator and round what they want you to do. Duh. Okay? So we are going to round to the nearest hundredths here. And let's go ahead and do this. Again, I figured out what my A, B, and C is. A is -3, B is 5, and C is -2, which means I am now ready to plug this into the quadratic formula. Like so. -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, that leaves me with -5 plus or minus the square root of -5 squared minus 4 times -3 times -2 all over 2 times -3. So let's go ahead and do some math. Again, order of operations, simplify, and remember to break your final, once you get the radicand simplified as far as it goes, again, everything inside the radical, everything inside the square root completely simplified, you're ready to break your equation, your formula into 2, the positive outcome and the negative outcome. All right, so there's the positive outcome, there's the negative outcome, simplify, and we're simplifying to the nearest hundredths, which means 2 numbers after the decimal, which is approximately 0.67. It was actually 0.6 repeating, but since we want hundredths, I need 2 numbers, which means the third 6 is going to make the second 6 into a 7, and there we stop at 0.67 approximately. And we also end up with just 1. So the 2 places where the parabola for this equation hits the x-axis is at about 0.67 and 1. Okay? And you could have probably also just left this at 2/3, but they kind of wanted you to have a decimal when they said that they wanted you to round to the hundredths. And hundredths kind of only happen in decimals. Okay. So let's go ahead and talk about a football player. All right, so remember, most negative solutions don't work in real-world situations. A football player kicks a ball with an initial upward velocity of 38.4 feet per second, from a starting height of 3.5 feet. Using the velocity motion formula, which is height is equal to negative 16t squared plus velocity times time plus c, where c is the starting height and t is the time. All right, so let's go ahead and visualize this. We have a football player, and he kicks a football, and it goes up, and then it comes down, and it follows the shape of a parabola. And basically, we want to know where the ground is. All right, at what time the ball is on the ground. Now, if the parabola were to continue off before the football player hit it or kicked it, that's where we'd be starting. But we kind of don't care about that. We kind of actually care about at what time the ball hits the ground after he kicks it. So technically, the ball's on the ground if the parabola were to stay the same on the left before he kicks it, which means we're at time pre-zero. Basically, this is time zero, right? And so over here is actually before the time started. So we're only going to end up having one solution for this, and it's going to be the positive one because we want to know what time after time zero the ball hit the ground, okay? And because the ball hit the ground, that's what we call height zero, all right? Height zero because it's the ball 0 feet from the ground. Yes, there's no space between the ball and the ground. Well, there's going to be some minuscule space, but you get the idea. All right, so let's go ahead and use this formula right here and plug in what we know. Well, we know the height needs to be 0, so h is 0. Time is still time because that's what we're trying to figure out. But the velocity is how hard and how fast he kicked the ball, and 3.5 is how high the ball was from the ground when he kicks it, when the ball starts experiencing this 38.4 feet per second velocity. All right, so now we're ready to plug this into our quadratic formula where A is, height of the ball 0, also known as when the ball hits the ground, which is right there. Okay, so let's go ahead and figure out my quadratic formula. A equals negative 16, B equals 38.4, and C equals 3.5. So plug it into the quadratic formula, blah, blah, blah. Simplify it. Great. Break it into two equations, the positive outcome of the radical and the negative outcome of the radical, and simplify. Well, that gives me negative 0.0879, and that gives me positive 2.5. So, again, remember, the negative version doesn't work for this because it's actually, the negative version is the height of the ball before he kicks it. So we don't care about that. We want to know about after he kicks it. Well, that's 2.5 seconds when rounding. Okay? All right. So when to choose an appropriate method. You're going to graph if you have an equation that looks like this or this. Square root if there's no x term. Factoring if you can factor easily. Completing the square if x equals 1 but can't be factored easily. And then quadratic. Well, guess what? You can use that any stinking time you want. All right. There we go. I'm done, guys. Bye.